Hi everyone, welcome back to the next session of periodic table. So, in the last session we have discussed some of the properties or characteristics about the periodic table, where we have discussed about the typical elements, bridge elements, diagonal relationship, valency, metallic characters, nature of oxides, etc. So, now as we have already discussed about the classification into several blocks, let us see their properties in detail. So, dear children, here is our next topic, electronic configuration of elements and the periodic table. So, all of you should take your NCERT textbook and see the picture about the blocks which is given in your NCERT. This is exactly the same one. Okay. So, here you are able to see 4 blocks: S, P block, D block and F block. So, the first 2 groups, your alkali metals and alkaline earth metals, belong to S block. 13th to 18th group elements are a P block. The transition series starting from 3 to 12 is your F block. The other 2 period which actually comes exactly after lanthanum and actinium, which are actually known as lanthanoids and actinoids, which are your inner transition series, is considered to be F block. Why this is known as inner transition series? Because actually they come inside the D block. So, here you have lanthanum and actinium, and soon after the element is cerium, soon after actinium the element is thorium. So, after lanthanum actually you are having this 14 elements which are known as lanthanoids, and then only the rest of the D block. So, it is actually you cut the D block and you place the F block into this, so that you are literally getting the long form of the periodic table. So, let us see block wise. First one we are discussing is about the S block. So, the definition is already discussed, because the last electron enters the S orbital and hence it is known as S block. So, let us see what are the elements. You have lithium, sodium, potassium, rubidium, cesium and francium. Okay. So, when you write their electronic configurations, so we will consider these S block elements. Let us take the first group, where you have lithium, sodium, potassium, rubidium, cesium and francium. I will take only the 3. So, lithium, its configuration is 1s2, 2s1, right. For sodium, this is 1s2, 2s2, 2p6 and 3s1. So, how can you write it? So, just follow the off-book principle. The atomic number of lithium is 3 and for sodium it is 11. So, you can directly write the electronic configuration. Okay. So, dear children, just try it and make sure that you are able to write the electronic configuration according to the 3 rules. Okay. So, come to the potassium, then you have 1s2, 2s2, 2p6, then what is next? 3s2, then 3p6, you have 4s1. So, when you write rubidium, again you are having very long electronic configuration, right. So, dear children, and the atomic number of potassium is actually 19. So, dear children, it is always very difficult to write the electronic configuration incomplete, because when you consider the higher atomic numbers, you are literally getting very long electronic configuration, right. So, in order to avoid that problem, we have introduced a method to write the electronic configuration in a very simple manner. Okay. So, for that, it is related to the electronic configuration of your noble gases. So, what are the noble gases? So, tell me, what are the noble gases? You have helium and neon argon, krypton, xenon, and you have radon, Rn. So, these are the noble gases. In order to make this writing simpler, dear children, you need to know their atomic number. Okay? So, just by heart the atomic number, it is not always required to by heart. You just need to have a scanned copy of periodic table. See, anyway we know that helium is having an atomic number 2 because it comes after hydrogen. It is the second element. So, the atomic number of helium is 2. You need to consider the atomic number of neon. So, as you know that in the first period or after helium, you are having second period. So, what is the number of elements in the second period? It is actually 8. So, after helium, the next 8th element is your neon, because always noble gases come at the end, right. So, the atomic number here it is 10. Consider the next one, argon. How will you find it? So, after neon you have argon. So, 10 plus neon is the last member in the second period. So, in the third period how many more members are available? Again you have 8. So, in argon you are getting 18, right. So, that is the atomic number, just add 8. What about krypton? Can you do this 18 plus 8? No, you can't do this. Why? Because when you consider krypton, you are at the 4th period, right. And as you know, in 4th period you are having a total number of 18 elements, because there you have transition elements as well. So, here after krypton or from krypton you have 18 plus. 18 is the atomic number of argon, and plus how many more elements are present? It is 18, because that is the 4th period, and you get 36. Consider xenon after krypton. So, krypton is 36 plus it is the next 18th element, and you get 54. What about radon? It will be 54, this is 54 plus 18, right. No, this is wrong. Why? Because when you consider radon, it belongs to 6th period. You know that in 6th and 7th period you have lanthanoids and actinoids, right. It is actually, even though it is placed at the bottom of the periodic table, they actually belong to 6th and 7th period, because they come after lanthanum and actinium. So, when you consider here radon, it will be 54, which is the atomic number of xenon, 54 plus you need to add 18, because anyway there are 18, plus you have 14 lanthanoids which are placed at the bottom. So, literally you are adding 32, right. 18 plus 14 is 32. So, whenever you are finding the atomic number of any element which belong to 6th and 7th period, which comes after lanthanum and actinium, you need to add 32 number. Okay. So, 54 plus 32 you are getting 86. Let us say what would be the very next element? After radon, what will be the very next element? That what will be the atomic number? So, how you are finding? You have 86, which is the number of radon, plus how will you add? It should be exactly 32, because there you have actinoids as well. So, along with 18 you need to add 14, which is the number of actinoids. So, here you are getting 118. You remember how to name 118. What will be the name given? This is unoctium, UUO. It is unoctium, which is your organoson, OG. Okay. So, these are actually the atomic numbers of the 18th group elements, which are also termed as 0 group or your noble gases. Okay. So, now this is very easy. You have helium 2, neon 10, argon is 18, krypton is 36, xenon is 54, radon is 86 and the next one is 118. If you can remember, that is your organocene. Okay. So, dear children, the numbers which are actually used to add are 8. In the next also we have added 8, 18 and here we have added 32 are known as magic numbers. Okay. So, these are all your magic numbers. So, you have all these numbers, right. So, magic numbers are the numbers which are used to add along with the noble gas in order to get the atomic number of that element that we are considering. Okay. So, hope you are now thorough with the atomic numbers. So, just revise it once again. What is the correct order of the noble gases as well as what are the atomic numbers. Okay. So, we are back here. You have lithium and lithium is having atomic number 3 and you know that 2 is the atomic number of helium. So, I am considering lithium. Okay. I am considering lithium. Lithium is having an atomic number 3 which is actually 2 plus 1 and you know that 2 is the electronic or 2 is the atomic number of helium. So, after helium there will be one more electron. So, 1s2 is the electronic configuration of helium. So, you can write this is helium 2s1. Okay. So, you consider the sodium. Here you have 1s2, 2s2, 2p6 and 3s1 and what about this? This is atomic number 11 that indicate atomic number 10 plus 1 and 10 is the atomic number of neon. So, how we are writing the sodium? Sodium can be written as the configuration of neon till here P6, every P6 is actually your configuration of the noble gas and you have 3s1. And there you simplify the electronic configuration. How will you write the potassium? That will be the next one. It is argon 4s1. So, this is how we will write the electronic configuration now onwards. Okay. So, for that you need to know the atomic numbers of all the noble gases. So, let us consider the next one. Okay. So, yes, here I have written that you have lithium, sodium, potassium, rubidium, cesium and francium. See, if this is not clear, this is what we have just explained. Lithium is written as helium 2s1, then sodium neon 3s1, argon 4s1, krypton 5s1, xenon 6s1, radon 7s1. Isn't it easy? So, this is how you can write. So, memorizing all these numbers, memorizing all the numbers or the atomic numbers will be truly helpful to you people in order to predict the position or the block number of any unknown element. For example, I am asking you, I am giving you an unknown compound which is 116. I will give you, you are having 116. Atomic number is 116. Okay. So, atomic number Z is 116. Can you predict the block it belongs to? So, how will you do that? So, you know that when you memorize all the atomic numbers. So, tell with me what are the atomic numbers? You have helium, you have 2, then you had neon 10, you have 18, 36, 54, 86 and then it was 118 which is your organocene, right. So, 118 belong to 18th group. Then what about 117? Belong to 17th group. Then 116 will belong to 16th group. And now it became very easy. Otherwise, it may be required to write the entire electronic configuration and to see which group and block it belonged to. So, now it is very clear, it belonged to 16th group and 16th group is a p block element. Which period will it belong to? As 118 belonged to the 7th period, it is very clear 116 is just 2 numbers before 118 will be exactly in the same period. So, this is very important, memorize all the atomic numbers of the noble gases. Okay. So, this is about the first group, which are known as alkali metals. You consider the second group alkaline earth metals. Okay. So, you can write alkaline earth metals, this would be your assignment for today's session. Write the electronic configuration of alkaline earth elements in this format, like you have helium, neon. So, in that format you need to write it. It is very easy, children, because in the case of beryllium you have one more electron than lithium. So, that will be helium 2s2, right. The next one, magnesium, will be neon 3s2. So, just do that and thorough this concept. Okay. So, when you consider before moving into p block, there are some points that should be remembered in the s block. Okay. So, here I will take a new slide. So, in this case s block, what are the properties that you know in common? S block elements, all these are, they are actually very soft metals. All the S block elements are very soft metals. So, you know that iron Fe, that is a transition element, and it is very hard, right, because you cannot break your iron by using a knife, that is not possible, and all the transition elements are much harder. Whereas, when you consider these elements, especially these S block elements, they are very soft, and these are the softest metals that you can see in this periodic table. For example, you consider sodium, hope you are well known with sodium. So, sodium, take a sodium and it can be cut by using a knife. Okay. So, it is very soft, all these are very soft, and as they are soft metals, they will have very low melting and boiling points. Melting points and boiling points. Okay. So, you know that what is a melting point or a boiling point, that is decided by the energy that should be supplied to melt a system, right. So, when the metal is very hard, you need very high energy in order to melt it. If it is very soft, you need less energy to melt it. So, as these are soft elements, you need very less energy to melt or boil them, and that is the reason why they are always with lowest melting and boiling points. Okay. And when you consider their sizes, which we will discuss in the coming slides, they are generally the largest atoms in the respective periods. They are the largest atom in their respective periods. Okay. For example, when you consider the third period, sodium would be the largest one, because size decreases from left to right. Okay. So, again there is a term called as ionization enthalpy. You remember the ionization enthalpy term in your exercise question in your second chapter, structure of atom. Yes, right. So, what was ionization enthalpy? That was the energy required to ionize. That was the energy required to remove the electron, right. So, when you have big atom, when you have very big atom, it is very easy to remove the electron from the system, because the size is so big that the nucleus cannot hold the valence electron very effectively. When you have small sizes, nucleus can consider all the electrons and they can hold all the electrons very tightly, because it is very nearer to me, I can hold all the children around me. When you are very far away from me, it is very difficult for me to reach a hand to you, because you are very far and the connection is very poor. So, the same manner, when you have bigger atom, it will be very easy to remove the electron. So, you consider you have a bigger atom, this is your nucleus. So, you have electron here, consider a small one, this is a nucleus and you have an electron here. So, which electron can be easily taken? And the first one, right? Why? Because this electron is far away from the nucleus, is not much attracted by the nucleus, is easily removable one. So, when you consider the size, they are the biggest or the largest elements in their respective periods. So, their ionization enthalpies are very less. They have got least ionization enthalpies because their size is so big. Okay? And there are even more characters. They can always impart color to flame except beryllium and magnesium. What do you mean by color to flame? You take the metal, heat or show this to a flame, you are able to see different colors in the flame. So, this is sometimes termed as flame test. So, this is a best method to understand the metal. So, all the alkali and alkaline earth metals will impart color to the flame except beryllium and magnesium. There are some reasons, we will come into that later. So, except beryllium and magnesium, all of them can show color to the flame. So, for example, when you have a barium, you are able to see the flame which is having an apple green color. For strontium, you have crimson red color. So, based on the color, they are imparting characteristic color to the flame, and I hope you can justify that based on the spectra, like when electrons are transiting, they releases color. Okay? So, that is the reason why you are able to see the flames. So, these are some of the properties of the S block element. Anyway, we have discussed its general configuration. Its general electronic configuration, how will you write, children? It is either NS1 or it is NS2. What is the outermost configuration? NS1. It is for your first group alkali metals, right? Lithium, sodium, etc. And for the second group, which are your alkaline earth metals, the configuration is NS2. So, in general, all together you can write this is NS1 to 2 is the general electronic configuration of an S block. Okay. So, this is about the S block element. Hope this is clear. So, what you need to study by this idea about the S block, you need to know all the S block elements. You need to know how to write the electronic configuration by using the atomic numbers of the noble gases. You need to know some of the properties of the S block element, and you need to know the general electronic configuration. Okay. Yes, so we are in the next slide, P block. This is also very easy, similar to the S block, very easy to learn. So, here you see all the elements. You have 13th group, which is boron, aluminium, gallium, indium, thallium. You should pronounce with me after me. Okay. 14th group is carbon, silicon, germanium, tin, lead. 15th one. Yes, children, tell me what are they? It is nitrogen, phosphorus, arsenic, antimony, bismuth. 16th one, oxygen, sulfur, selenium, tellurium, polonium. What are the 17th group members? Tell me. Fluorine, chlorine, bromine, iodine, astatine, you have neon, argon, krypton, xenon, radon. I have not written helium. Okay. So, think why helium is not included in the slide. So, dear children, we will be back with the same question in the next session. Thank you.